Welcome to the physics quiz brought to you by QuizX. I'm Clinton Baptist, your neighborhood quiz master, founder and CEO of QuizX, and people call me QHead. And I'm the host for this quiz, and I'm really excited to host this quiz because we have bright, innovative young minds with us competing for the top spot. They're representing three finest PU colleges in Mangalore, and they're competing for the title Mangalore's Best Physics Team. So let's see who will, I'm really curious who will get this title of this year, 2024 Mangalore's Best Physics Team. We have a team from CFAL, Center for Advanced Learning. We have team from Lourdes Central School, CBSE, and we have a team from St. Aloysius PU College. This is like a knowledge face-off, it's like a knowledge sport, and I'm really thankful for the respective colleges for sending their best team. Whenever I went to invite colleges for this quiz, and most of the colleges were quite busy making students prepare for competitive exams. I know preparing for competitive exams is crucial, but what's also crucial is staying updated with the fields you love, like to know what's happening, what are the new ideas coming up. That way you get the motivation, inspiration to do something in your field. Let's get this face off, this competition on the road. May the best team win. And before we start, I would like to thank TLC Art Cafe for providing this beautiful space. And and also there is a character in town called Grizzly Bear. It has sponsored a winning prize for you guys, and that is 1 kilo grizzly brownie. So whoever wins this quiz will walk home with the title with a 1 kilo grizzly brownie. I mean, it knocked on my door last night. When I opened the door, there was a bear, and it handed me a package with a note. And when I read the note, it read, "The package belongs to the winner." And it just disappeared. So when I opened the package, there was 1 kilo brownie, which may be now 900 grams. All right, so you guys are ready? Yes. Okay, before we start, we will have the introduction. Let's know each other. The teams are cheering you up from YouTube. Introduce yourself with your name, your aspirations, and followed by present obsession. So we'll start from team CFAL.
Hello. I'm Vamshitha. I'm from CFAL PU College, TLC PU College. And my current obsession has been a choreography that I watched recently. I'm a dancer, and my aspiration is to become a physicist.
Nice. Which physicist?
Astrophysicist.
Nice. Any personality out there who influenced you to
My
think about
physics
astrophysics?
My physics teacher.
Nice.
He's a really big inspiration.
Who is it? Okay.
Mahesh sir.
Mahesh sir, okay.
Hi, so I'm Ira Jain, and I'm also from the TLC PU College. I would like to be a researcher in physics itself.
Any particular, like theoretical physicist, experimental?
Not really sure right now.
Okay.
Mostly in experimental physics. Yeah, and something interdisciplinary maybe. Yeah, and my current obsession, maybe quizzing itself, because like I went to a quiz this week and then I'm here today. So yeah, really obsessed with quizzing for this week.
Nice.
Yeah.
Nice. Do you have any favorite quiz master or something?
Big Brain.
Big Brain, okay.
Cool, yeah.
Nice.
Hi, so I'm Rishabh Naik. I'm also from the TLC PU College, and my current obsession is actually Formula 1.
Nice, okay.
Yeah.
Who is your favorite racer?
Max Verstappen.
Nice.
After the previous race, I want to pursue my engineering in prestigious college. Which engineering branch I haven't yet decided. But,
Computer science?
No, I can't do computers.
Okay.
Mechanical, or I might go for electronics and communication.
Any particular science instrument or mechanical system you are really love working with?
Turbines.
Turbines, nice. Yeah, let's go on to team from St. Luke's.
So my name is Chirag, and I am currently preparing for JEE Mains. So my current obsession is I just want to, look at problems and solve it the way they are actually present in nature without taking any assumption. like as natural as they are possible.
Without any bias.
Without any assumption taken. I'm obsessed to solve such problems, and I want to see myself in prestigious institutes.
My name is Amber. I'm also from Lourdes. I'm also preparing for JEE mains. I wanna go to bits mostly. I like listening to music. I sing, play some instruments.
Favorite artist?
Queen.
Queen, nice. Wow. I didn't expect that. Nice taste.
More into old music.
So my name is Adesh. Even I'm from Lourdes, and I'm planning to write NEET and pursue surgery.
Surgery. Okay.
Yeah.
Any particular?
Probably neuro or
Neuro.
cardio.
Wow.
Yeah.
Nice.
So obsession, just trying out new things. I want to be more practical, not stick to the books and more.
Nice.
Trying.
Explore.
Yeah.
So what did you explore this week?
This week I'm for this competition. I wanted to learn more about physics, my favorite topics.
So you're well prepared for the quiz. Yeah.
Kind of.
Let's see.
I just want to be practical. Explore.
Nice.
Yeah.
Nice. Let's
Thank
move
you.
on to team from St. Aloysius PU College.
Hello everyone, myself Adesh Shenoy and I'm from St. Aloysius PU College, and my current obsession is like my all-time obsession, and that's saving animals.
Saving animals.
Yeah, actually.
Okay.
My aspirations are to become a dentist and stuff like that.
Any particular influence you had to become a dentist?
Actually, no.
Okay. Did you have a painful dentist surgery when you were young?
No. That's why I like dentistry.
Hello everyone, I'm Leroy Savio Pereira from St. Aloysius College, and I'm currently obsessed with watching cricket, and I spend a certain amount of time listening to music, like during the night time after studies, and my aspiration, I would like to do something in biology or maths.
Which is your favorite cricket team apart from India?
It would be South Africa and New Zealand.
Hello everyone, my name is Sohan. I'm
Sohan.
from
Sohan, okay.
I'm from Aloysius PU College. My obsession, I don't have that much of an obsession. I watch some series now and then. And then aspiration, I'm going to write JEE and become an engineer. Not deciding which one, but like yeah.
Computer?
No, aeronautical.
Aeronautical, nice. So you mean you like jets?
Planes, yeah.
And you guys know more than what I was in PU. Like, PU, the questions I designed is quite hard, which if I were to look back when I was a PU student, I wouldn't even answer a single question. But I'm pretty sure you guys will do very well. You guys are ready? Okay. There are 4 rounds. Write your answers in the paper and show up when I only ask you to. So no changing your answer from what you have written on the paper. First round, guess what? And second round, act it out, which is charats. Third round, think. Fourth round, risky trivia. Round 1, guess what? Presenting you guys series of images. Number of questions 4. Correct answer 20 points. Wrong answer, no negative. And your first question. Guess what? Everybody has the answer. We'll start from Team CFAL.
Rings of Saturn.
Rings of Saturn. Does it look like a rings of Saturn? What
Yes,
made you? What
like-
particular image made you think it's a ring of Saturn?
There were like close-ups, right? And it looked like rings of Saturn.
Nice observation. Okay, moving on to Team Lourdes.
Rings of Saturn.
Rings of Saturn. You're going with the same answer.
Yeah.
Nice. Team Aloysius. You guys moving with the same answer, or you guys have the different answer?
It's a volcano
Volcano.
and the rings of Saturn.
Like one answer. Like you have to pick one answer.
Rings
Like,
of Saturn.
can I see your paper?
Yeah.
Show it up. You guys have 3 answers. Pick one. And going forward, only one answer will be considered.
Yeah, the rings of Saturn.
Sure?
Yeah.
Okay. And what did you think, volcano?
Last one. Yeah, it looked like a volcano.
Okay. All right. So everybody has the same answer. And you guys are right. It's rings of Saturn. And I can give you bonus points if anybody can tell me which spacecraft took these photographs? Write your answer in the paper. Bonus of 10 points. Yeah, 5, 4, 3, 2, 1. Yes. Hubble telescope. Yes. Callista. Okay. What is the answer?
Apollo 13.
Apollo
13.
13. Nobody got it right, but nice thinking. The answer I was looking for, Cassini. Okay. It was sent in 1997, I guess. It took 7 years to reach Saturn. And it was active from 2004 to 2017, probably 12, 13 years. And it has revealed a lot of details about Saturn rings. What are they made of? They're not uniform ice crystals, boulders, and how these rings, are formed and influenced. It's shaped by gravitational force and Saturn moons. I like the way you guys started. Nice. Everybody gets 20 points. And moving on to the second question. The one you see is a Belgian Catholic priest and is also known as father of Dash. What's his contribution to physics? He once collaborated with Einstein. He proposed something that Einstein resisted. He said it can't be possible. Then he showed the mathematical possibility of his proposal, which led to Einstein's acceptance. He put forward something quite groundbreaking at the time and which is now well accepted. He not only postulated that, but also came up with mathematical reasoning for why it is so. Google came up with a doodle to celebrate his birthday. And this is his doodle. Five, 4, 3, 2, 1. Okay, we will start from Lourdes team.
It's the field he was in. We are not sure about the name. It's probably from the field of quantum mechanics.
Quantum mechanics. So what did he propose?
We are not sure about that.
Okay, you mean he could be the father of quantum mechanics?
Yes.
We'll consider that as the answer. Brilliant thinking. Yes, moving on to team Aloysius. Yes, what do you guys propose?
Yeah, the scientist is Heisenberg.
What is the father of?
He proposed the uncertainty principle.
Uncertainty principle, yeah. Interesting. So you guys have quantum mechanics as the answer. So any particular to add on to that? Like why did you guys think so?
Dual nature of light and particles.
Dual nature of light. Nice. Everybody has the same answer. What it shows is everybody is neck to neck. This is what I love about being a quiz master, when every team is neck to neck. The answer I was looking for is something you don't expect from a Catholic priest. Big Bang. So he was the first one to propose Big Bang theory. So he said universe was made of primordial atom, and it started with the explosion. And what he proposed to Einstein was universe was expanding. So back then, 1920s, 1930s, people had a conception of static universe. Universe is just the way it is, like static. So he was the first one to propose universe is expanding. Moving on to the third question. You see in the picture, it's one of the humanity's greatest accomplishment in physics, or maybe overall, like to understand the truth. What is it? This was a very clever engineering to find the truth. We'll start from Team Aloysius. Yeah, what is it?
Aerodynamics.
Aerodynamics. So what is the, can you elaborate your answer?
Yeah, the space shuttle and the workspace.
So they're trying to find the aerodynamic efficiency of something.
Yeah.
Like any particular thing in the picture that made you think it's the aerodynamic experimental setup?
Yeah, the workspace. The lab.
Workspace. Okay. Interesting. Nice thinking. Coming on to Team CFAL.
So it's a particle accelerator.
Particle accelerator. Quite expected. Nice. What made you think it's a particle accelerator? Last picture with the tubes, long elongated tubes. Nice. So what is the truth that they're trying to find?
Higgs boson.
Higgs boson. Nice. Yeah.
What we wrote was Large Hadron Collider or CERN.
You guys have the same answer, which is again particle accelerator. Nice thinking. Anything add on to your answer?
The tubes was the
tubes,
part
yes.
that because they use large tubes to accelerate particles
Nice.
to very high speeds.
Any idea on how long the tubes are?
30 kilometers in range.
Nice. Quite accurate. And why I put those tubes is quite intentional. It is not particle accelerator. It is something else that has started a new field that has proved something which Einstein predicted 100 years ago. The answer is LIGO. Laser Interferometer Gravitational Wave Observatory. So what the setup is, they send lasers, these large tubes in perpendicular, and there are mirrors, and there's laser inference. What they're trying to find is gravitational wave from the outer space. The gravitational wave caused by black hole merger or other astronomical phenomenon which ripples space-time fabric. Like Einstein predicted that long back, but nobody has proved it experimentally if it's true. It was true mathematically, but it was not true experimentally. So this is the experimental setup, huge project which received Nobel Prize somewhere, I don't know which year it was, and this gave rise to new field, gravitational observation physics. Yes, so this helps to observe the events happening, like mega events, black hole merger that can ripple, which is light years away. Okay, fourth question, last question of this round. I'm going to show you an instrument which is very sophisticated. Invention of which, and also the discovery of the principle which it operates on received a Nobel Prize somewhere. So what is this instrument? If you guys know the exact answer, I'll give you full points. If you guys can tell me something pretty close, I'll give you half the points. Yes, we'll start from Team CFAL. Spectroscopy, nice. Yes.
Something in spectroscopy.
What is spectroscopy? Why is it used for?
Spectra, so the line spectra of atoms and all of that, using that stuff.
To find the composition of something, using how it behaves in the form of light. I mean, when light is subjected, emitted.
The radiations it emits.
Beautiful answer. Yes, Team Lourdes.
Our answer was electron microscope.
Electron microscope. Nice. What made you think it's an electron microscope?
The fact that you can see a lot of minute objects up to very high definition. Like it has opened up a new world for us to see biology up close.
Nice. Brilliant answer. Nice. I like the thinking. Yes, Team Aloysius.
Electron microscope.
Electron microscope. Same answer. Why? Yeah. What made you think it's an electron microscope?
Electron, it is used to view the smaller objects which we cannot see in our naked eyes.
Okay.
And electron microscopes are more developed. Electrons are found in an atom. they are so small. So yeah.
All right. So we'll see. Nice thinking. One of you guys have come close. They get up the points. Scanning, tunneling microscope. So since you guys came close, I'll give you 5 points each for coming up with the microscope. This is much more powerful than electron microscope, called tunneling microscope, where you can see the atomic bonds. Electron microscope, you can just see the virus, bacteria. With this thing, you can see atomic surface and bonds forming in real time, atomic bonds. So, and how it operates is quite interesting. So you can look it up, how scanning tunneling microscope works. This is the end of round 1. So we'll read out the team. Team CFL 20 points. Team Lourdes 25 points. Team Aloysius 25 points. Round 2, act it out. So a topic is shown. So you have to pick who will act. And no using alphabetical strategy, A for apple, B for ball and all. Yeah, you will get 90 seconds. We'll start from highest team, Team Aloysius. You guys will act it out first. I'll show you something.
2 words.
First word.
Okay.
Open the door.
Open the fridge.
Walking out.
Stay here, okay? Stay here. Yeah, stay in the
Going out. Scroll. 2 words.
2 words. Aeroplane.
Car.
Flying cars. Breeze.
No, opening the door he told, and now it's breeze. Push. Pull.
Use physics terms. This is not regular charash.
Aircraft.
30 seconds more.
Going out. What's more
Enthalpy.
Other side. Other dimension.
No, stay in the frame. You're going. Yeah. That is the clue actually. Yeah, going out of the frame. 10,
Dimension.
9,
Dimension.
8,
Dimension.
7, 6,
Going out of
5,
2D dimension.
4, 3, 2. Done. Don't reveal the answer. Don't even tell them. Okay. Go back to your place. The answer was escape velocity. First one was escape, and second one is velocity. That's why I use physics term. Don't tell push, pull, or something like that. All right.
You at least.
Okay, was it fun?
Yeah.
Okay, second from Team Lourdes.
Yeah, you are tied up for everything. You are.
Yeah, quite difficult. Nice, but I think you had it. Did you guys had this? You know what this is, right? Okay. Confident. Wow, you look confident. Nice. Your time starts now. Use the mic, okay? Yeah.
How many words?
Didn't look like escape.
Something vectors. Something vectors. Tangential something.
Coil.
Wow! Brilliant answer. Congrats. Nice acting. Nice team. Congratulations. It was indeed vernier calipers. Great job. Team Lourdes, you get 20 points. Team CFAL, who is coming?
We told dimension.
Your time starts now.
Photoelectric effect.
Whoa! Get it right, broke the record. Photoelectric effect. 20 points. So that is the end of round 2. So Team Lourdes is leading with 45 points, followed by Team CFAL 40 points, followed by Team Aloysius 25 points. Okay, round 3. It's called Think. Total 5 questions. No negatives if you get it right. Sorry, if you get it wrong. If you get it right, 20 points. And if you think like exceptionally, if I like your answers, the way you think, the proximity to the real answer, the way you connected dots, you can expect bonus point from Quizmaster. First question. Think over chaos and complexity. So there is a field in physics just on chaos, just on studying complexity. Chaos and complexity theory in physics show that even random systems have hidden patterns beneath their unpredictable surface. Even minute changes in initial conditions can lead to drastically different outcomes, which is popularly known as butterfly effect. In a sense, when the flap of wings of butterflies at Amazon can cause a tornado somewhere else. It means a small, minute thing can cause something huge. This sensitivity to initial conditions make long-term predictions nearly impossible in complex systems. That's why predicting exact weather tomorrow is really impossible, because weather patterns are highly unpredictable, because there's so many factors at play. It is a system of complex system. Like any small thing can influence its result. And even for that matter, population dynamics, how people behave, even stock market is example for complex system. In the 1970s, mathematician Benoit Mandelbrot uncovered that these chaotic systems often generate fractals, patterns that repeat themselves at different scales. So the example you see in the picture, you see complexity, yet there's patterns at different scales. This is called fractal diagrams. These self-similar structures appear throughout nature, from branching patterns of trees to the intricate structure of snowflakes. Researchers studying complex systems notice that when systems are balanced between order and disorder, called edge of chaos, they become highly innovative and adaptable. So there is a state called edge of chaos, where you're not in the order state or not even in the chaos state. You are in the edge of order and disorder. And you guys use ChatGPT. That is the result of operating this machine, this language models at the edge of chaos, where the model is at that state where it can come up with innovative answers. Not very wrong, not very hallucinative, at the really right balance. So this idea led to advanced AI algorithms that solve problems more effectively. Yes. And interestingly, even human brains sometimes operate at this state, edge of chaos. Almost everyone has this capability, and that's what makes a species unique. There are neuroscience revealed that human brains itself operate at this edge of chaos. When solving complex problems, neural activity shows patterns to those found in complex systems. Scientists observe that certain mental states allow for optimal information processing and pattern recognition. So think of what state of our mind is where we process information very efficiently, optimally, and also pattern recognition. So what is this mental or cognitive capability? So when individuals enter this mental state, there's a formation of novel connections, making the neural patterns demonstrate a perfect balance between randomness and structure, much like the system studied in chaos theory. My question is, what do you think is this mental process that operates at the edge of chaos? You have got 20 seconds. At this mental state, we efficiently and optimally process information along with pattern recognition. And maybe you guys are experiencing that edge of chaos in your brain right now. So you guys, what you're doing is processing the information, what you just saw in the slide, optimally, efficiently, and trying to recognize the pattern, and that's what's going on. We will start from Team Lourdes.
Wrote down slow state.
Flow state. Wow, brilliant answer. What made you think it's a flow state?
Usually with patterns and stuff, it's usually something to do with our cognitive abilities. So there have been many theories stating the flow state.
Right,
as something-
where you work very efficiently and
Where your brain is at its peak activity. You
Right.
start forming patterns. You start
Right.
recognizing patterns. So this is often used in therapy sessions. Usually,
Mhm.
philosophers also use this.
right.
And it has become more popular in recent days where they use this for academics also.
Right.
Students learn
Mm.
this flow state, how to
Right. Right.
use
The-
it
yeah.
efficiently.
Flow state is very dependent on neurotransmitters like epinephrine. I don't
Yeah.
recall exactly
Yeah, all that.
neurotransmitters.
Generally, it's activated when you're solving something you're more interested in.
Interesting and also challenging. There is
Yeah,
a
and also
certain
challenge,
challenge you
yeah.
want. Like you can't be in a flow state when it's very easy.
And boring. Yeah,
Right.
That's the
Interesting. Very interesting. So let's see. Let's go with the team. Aloysius, what do you guys have?
We also wrote flow state. It's like when it's actually at the edge of chaos as well. Flow state. If you do flow state properly, if you get into the flow state correctly, you can maintain order. But if
Hmm.
done wrong, your brain will create fake scenarios and it'll lead to disorder.
Wow, very great observation, huh?
Yeah.
So,
And
do you practice flow state?
yeah, sometimes
Okay, what do you do to get the flow state?
it's only when I do things that I like solve math problems.
Okay.
Like, that's only when the flow state occurs to me.
All right. Nice, very interesting. Yeah, we'll go on to team CFAL.
We were also thinking along the lines of flow state.
Okay.
But also like the subconscious mind.
Mm-hmm.
So there is this thing where you're like just about to sleep. Like when you're in that state where you're like about to sleep, but then you're not fully asleep yet.
Mm-hmm.
That state.
What is it called? So you mean stage where you're about to sleep
Yeah, and there was something.
and you are
about-
also
I
awake?
think- I'm not sure. I think it was Einstein. I'm not sure, but he would go into thought processes on a rocking chair with a key or something noisy.
Ah,
and-
that was Salvador Dali.
Okay, fine. And then he would
Painter.
rock his chair, and
Mhm.
like he would reach this state,
Right.
and then just when he would drop,
Hmm.
when he would like, he's gonna fall asleep. So of course the key or whatever
Right,
would drop,
okay.
and that state. So yeah, it is a form of flow state, but it is at that
Mhm,
juncture.
mhm, mhm.
Yeah.
Loved the answer. Nobody got it right, but I would give it to Aloysius and team Lourdes 5 points for coming up with flow state. This is good, interesting answer, but the proximity to the answer or something is quite more there on that side. So the answer I was looking for, creative thinking. Yeah, it happens when you think creatively, or brains patterns, process information efficiently, and you solve, recognize patterns somewhere else, and come up with the creative solutions. This is what happens. Our brain operates at the edge of chaos. Think over pollination ideas. I'm going to present you a pollination problem. You have to come up with a very nice solution. In 2020, researchers from Japanese universities named the Japanese Advanced Institute of Sciences School of Material Science pioneered a new pollination method. Their research focused on using eggs to pollinate pear orchids while preserving flower integrity. They came up with a very simple, very effective idea to pollinate these very sensitive flowers. After testing 5 commercial products, they identified lauramidopropyl butane as the most effective agent for pollen germination and growth. The team later modified the idea by optimizing its pH and adding calcium and other ions to promote germination. Closely look at the image. That is what A20AB is, like molecular. So he bought something which is named A20AB. They tested many commercial available things for the idea, but finally they chose A20AB as the most effective agent for pollination. When deployed in the pear orchid, each X carried approximately 20,000 pollen grains to target flowers. The successful fruit production confirmed the method's effectiveness. Something used to carry pollen grain, and each dash something carried over 2000 pollen grain. Think outside the box. And usually, what do you guys think when you think of like when bees face extinction? There's a big problem with the pollinization, right? And it's a very global danger. So many scientists, engineers think robotic bees as a solution for bee shortages. This idea is more frugal. Like this idea is very much simple over these robotic pollinators. So this is a very good alternative for artificial pollination, which is conventionally in the science magazines, and when you read, what they propose is robotic bees or robotic pollinators, which is automated, which is quite advanced, very expensive, and not also effective. Not effective that much, but their idea is so simple that anybody can do it. If you had to solve this problem, what would you do it? So my question is, what do you think was the idea? All right, 5, 4, 3, 2, 1. So we'll start it from Team Aloysius. Yes.
Well, we wrote small birds.
Small birds, like hummingbirds?
Yeah, hummingbirds.
Okay.
It's because 2000, it's like a huge number. And
2000 pollen grains, so very yeah.
Okay. And pears grow on trees, so like high heights, small birds can fly up there.
Mm-hmm. The flowers are sensitive, no? So the beak is quite
beak
sharp
is also
and
thin,
they can
and easily they can pollinate.
Nice, interesting idea. We'll come on to Team CFAL.
We think it's bacteria.
Bacteria, wow, interesting. Quite outside the box, yeah.
Because certain bacteria, they have the ability to multiply whatever DNA that they have, and they share it.
Okay.
Yeah, because for survival basically, and also we thought the image that looked something along the lines of a protein.
Okay. So how can bacteria can carry pollen grain? Like bacteria is million times smaller than a pollen grain. So
there was a size mentioned that said 100 micrometers.
Mm-hmm.
There was an image, so we noticed that.
Interesting. But no, how can bacteria carry a pollen grain? Oh, you mean a group of bacteria?
Yeah.
Okay.
And they also had to alter their pH, right? Maybe they could create something with bacteria.
Culture of bacteria is like a biofilm. Okay. And how can they pollinate? Well, suppose you're creating a bacterial culture here. So you let it dry and let the wind carry bacterial thing, is it, along with the pollen grain? How do you pollinate with that? Okay, we'll come to Team Lourdes.
So instead, we are making the pollen stealers or non-pollinating, the less common pollination. So instead of adding something to the different animals, we can make the plant pollen grains more susceptible to stick to non-pollinators. Like there are some insects that don't pollinate, so they just lie for they steal the nectars or something in the leaf. So if you make these pollen grains, for example mosquitoes, we make the pollen grains more susceptible or more sticky, like adding the chemicals. So it doesn't alter anything, it doesn't damage pollen grains or anything, but instead it just makes it more sticky.
Yes,
so
the answer makes sense.
Yeah, so it can stick to the organisms which are less likely to pollinate usually.
You mean they came up with the glue from the commercial market?
Sort of like a glue.
So that was a glue, that A20, that the product I showed you was a glue, and that can increase the stickiness of the pollen grain so much that even non-pollinators can pollinate.
Yeah.
Like you mentioned, nice example, mosquito.
Yes.
Nice, brilliant. What do you think how the answer was? Makes sense. It connects the dots, like coming up with the gluiness, stickiness, because I mentioned the commercially available product, right? Glue is commercially available. So that was the dot you connected. So the points I give based on the dots you guys connect, like how close. I'll give you 5 points. That's not the right answer. I'll give you 5 points. The answer is quite simple and very, let's see, soap bubbles. That you see was a detergent. Detergent, you have that lipid layer, no? Like you guys saw in the picture, there was a lipid layer as the commercially available soap. And you guys make bubbles are airborne. Think like a space engineer. Okay, there is a equipment called Advanced Plant Habitat, APH, and it's one of the largest fully automated plant growth research facility on the International Space Station, where scientists study plants, plant growth, plant-to-plant interaction, plant microbial interaction, and study the plant growth under microgravity. If you have to be a space-faring civilization, or if you have to be in space, we should be able to grow things on space. This experimental setup is the stepping stone for that direction. So this is how it looks like. You can study many plants like potato, chili, and grass. APH is a fully enclosed closed loop system. When I mean closed loop system, like whatever it emits, carbon dioxide or other metabolites, it stays in the system. That is utilized again and goes back to the plant. So it is circular. Loop is closed. With environmentally controlled growth chamber, it uses red, blue, green and broad spectrum white LED lights equipped with 180 sensors to monitor its growth on every aspect: dimension, temperature, pressure, gas pressure, everything. The system relays real-time information including temperature, oxygen content, moisture level in the air, soil, near the roots, at the stem, at the leaf levels, back to the team at Kennedy Space Center. The Plant Habitat Avionics Real-Time Manager provides real-time data telemetry. The team is sitting in the Kennedy Space Center. There is a transmission of data. So the team monitor here. They control all the temperature, pressure from sitting here. Remote commanding and photo downlink to the team at the Kennedy. Quite interesting, right? The APH also features an active watering system with sensors that detect when plants need water, ensuring optimal hydration. There's one critical aspect of the plant health monitoring, which is temperature measurement. Traditional contact thermometers could damage delicate plant tissues, especially in microgravity where plants may grow in unusual patterns. Additionally, the act of measuring could alter the plant's temperature. My question is, how do you think this equipment measures plant temperature without disturbing the delicate balance of growing environment? So what is used to measure plants' thermal readings, like plants' temperature, without contact? Five, 4, 3, 2, 1. We'll start from team CFAL.
So, something to do with the emissions in that system.
Nice.
Emissions, the interactions that go on in that system.
Like emission of what particular? Carbon dioxide.
Yeah, the radiations and the gases particularly. And the gases, the emissions and the interaction of the molecules of the gases. Yeah.
Nice.
Interaction of those.
So you mean based on the concentration of the emitted carbon dioxide, you can inversely, like indirectly measure the temperature in the system?
Yes. And
temperature of the plant, sorry, not the system.
The system is fixed because it's a closed system.
Right.
So, to do with the pressure, so that's again the interaction of those molecules.
How can you detect plant temperature using pressure or concentration of something?
So, it's gases, right?
Mm-hmm.
So, for gases, you have relations between their pressure, their volume, their temperature.
But you are measuring the temperature of a living system, not because non-living system, the equation is straightforward.
Yeah,
but with the plant system, which is living, there are a lot of factors in play.
The temperature of that system would affect the temperature of its surroundings as well.
Mm-hmm.
So
I'm going with the first thing you uttered, which is the concentration of gases released by the plant, which you can indirectly measure the plant temperature. Interesting. We'll move to Team Lourdes.
So what we were thinking about was thermodynamic equilibrium. And like for example, we keep a sensor which is at constant temperature, and if we monitor the object's temperature, if there is a small change in the temperature, there is going to be a decrease or increase in the temperature, through which we can keep in like it has to be in equilibrium with the system. So what I'm thinking about was
Okay, you mean the total thermal energy, total energy of the system has to be equal, constant. So there can be change in any one of the change in temperature in any one of the components. So you can balance out, keeping in mind the fixed fixed energy in the system. Is it?
also you can measure in terms of CO2, like it's already stated by them. So if there is a temperature that is higher than required or lower, the plant will get strained. So there will be a variation in the amount of carbon dioxide consumed by the plants, and this can be observed because plants usually at a specific temperature consume a specific amount of carbon dioxide. So if the plant undergoes some strain, it's going to show abnormal variations, like it might not consume as much carbon dioxide it's supposed to consume, or it might consume more to stabilize itself. So these changes can be monitored.
Interesting. Yes, Team Aloysius.
And we wrote infrared rays.
Wow, perfect. Okay, what made you think infrared?
It's because, see, thermometers...
Which is non-contact. If I stay
yeah.
here and want to measure your temperature, I can just point infrared reading. Is that?
Yeah, like that.
Which is non-contact, doesn't contact the plant.
Yeah, even in our class, our physics sir told us that during COVID times, they used this technique because contact was not allowed that
Right.
time. Yeah, and there'll be no contact.
You guys thought exactly what is needed, infrared sensors. So, which is non-contact. Sometimes you have to think inside the box, not complicate things. Yes. Team Aloysius would get 20 points. Think like a quantum physicist. Okay, in 2024, a team led by Robin Wadsworth of Harvard University made a fascinating discovery about a common molecule. So they found a strange quirk. Quirk is, you guys know, what is quirk? It's like motion or twerk, something like that. In its quantum structure that had puzzled scientists for decades. This quirk involves two different ways that these molecules can move or wiggle. And they saw two things in play. One is hula hoop-like motion, where carbon atom swirls around the central point. And second type of motion was stretching motion, where the oxygen atoms bob toward and away from carbon center. And there were two mixture of these motions. One set of doing hula hoop motion, another type of doing stretching motion. What's remarkable is that the energy required for the stretching motion is almost exactly double that of hula hoop motion. So for it to move or stretch, you need to apply some energy, right? Without that energy, there is no motion. So the stretching takes double the energy of hula hoop motion. This seemingly random coincidence allows the two motions to mix in a phenomenon called Fermi resonance, which is average of atomic motions. As a result of this quantum quirk, as a result of this quantum motions of this molecule, these molecules can interact with a wider range of infrared light than most other molecules. What makes this molecule special to something, which is responsible for something, is because of its quantum quirk, where it has two types of motions. Because of these motions, it can enable this molecule to interact with a wider spectrum of infrared light. Scientists had known about these molecular motions for years, but their significance had remained a mystery. And this experiment, this scientist gone to a greater extent to explain this in a quantum level. And this scientist connected the dots, revealing how this microscopic behavior of these molecules have a far-reaching consequences on a bigger scale. What did they exactly do is they gave a quantum explanation for something, which is a very big phenomenon. You know what is quantum is microscopic atomic level explanation for something. So what did you guys just see? That is the quantum level explanation for something. That is a broader phenomenon. Okay, what is this quantum explanation for? Answer is quite simple. Don't complicate things. We will start with the team Lourdes.
We are thinking energy conservation.
Energy conservation. Can you elaborate? It's a broad term. I mean, energy conservation is everywhere. It's a universal phenomenon.
Resonance in organic molecules.
Resonance. Okay. Why organic molecules show this type of resonance? Okay, something like that.
Stretching between the oxygen and carbon atom.
Okay.
Going to Earth and coming back. It reminded me of the partial double bonds.
Interesting. Like, I mean, your answer reminds me of that benzene structure that Kekulé came up with. Yeah, nice, interesting. Okay, Team Aloysius.
We wrote interaction of protons, like proton-proton interaction.
Proton-proton interaction.
Yeah. And also the movements you described, they were like a day-to-day example of a yo-yo. How it stretches and it rotates in its place. When you throw the yo-yo, you require more energy and it automatically rotates itself while it's falling down.
So you mean proton-proton interaction, how proton and proton interact to form a nucleus of an atom.
Yeah.
How nucleus forms. Even proton and proton is positively charged. According to theory, it must be supposed to be repelled.
Yeah.
And you gave the explanation for why they form a nucleus at the center despite having like charges.
Yeah.
Interesting answer. Yes, team CFAL.
I think we'd go with resonance.
Resonance, okay.
So the resonance hybrid structures all have the same bond length.
Okay.
So the stretching and compressing motion of oxygen, I think, could be the quantum explanation.
Okay, interesting. So what molecule are we were talking about? Carbon dioxide. So what could this be the explanation for?
The shifting of
No, quite simple. Is the explanation for greenhouse effect, global warming. Because of the stretching motion, it can absorb more infrared light. That means more energy, more warmer. It can trap more energy. And this is the quantum origin of greenhouse gas effect. Why it traps more heat? It's because of the quirkiness, quantum quirkiness. Last question of this round, which is think like a Nobel laureates. In 2024, John Hopfield and Geoffrey Hinton, and these were the Nobel Prize winners. Okay, you guys seem confident. All right, let's see. So they won the Nobel Prize in Physics 2024 for their work in machine learning and artificial neural networks. They applied concepts from physics to develop key tools in modern artificial intelligence, which has become part and parcel of our life. Hopfield created an associative memory network, similar to a system that can reconstruct damaged images, but for data patterns. He based this on the behavior of tiny magnets in materials. Hinton advanced these ideas by developing something called Boltzmann machine, which learns to identify important data features autonomously, much like recognizing cats in picture without prior information. So they mimicked the neural structures, gave rise to neural computing, like mathematical foundation. So what's fascinating is, even though they seem like a discovery in computation, why did they get a Nobel Prize in physics? And that's what intrigued me. Like when I researched more and more, what happened is they applied the mathematical tools from a particular field in physics. And that field of physics studies the interaction of materials. Took the mathematical tools used in this field of physics to computation that gave rise to new form of computation like neural computing. This connection between computation and physics has led to the advancement of AI such as image recognition and language processing, which we use every day these days. So my question is, what is this branch of physics whose mathematical tools did this scientist adopt it to develop a Boltzmann machine? Which is this branch of physics? Like if you were curious why this scientist awarded Nobel Prize in Physics in spite being a computational discovery, the fundamental level, there was physics involved. So my question is simple, what physics? Like what part of physics? Alright, let's see. We'll start from Team Aloysius.
Electromagnetic resonance.
Electromagnetic physics. Okay. Why? What made you think it's electromagnetic?
Memory.
Nice association. Team CFAL.
We were thinking along the lines of the standard model.
Standard model in physics.
Well, bosons, something to do with that.
Okay. Can you elaborate more, like why studying boson can?
Fermions, leptons, bosons, those particles.
Particle physics. Okay. So you mean they took the tools from particle physics?
Yes.
Nice.
So, my answer was also going to be like fields. It's because
Oh, field? Which?
fields, like electric field.
Electric magnetic field. That was the answer. Okay.
So, what made me think about these lines are the modern phones that we use. The LCD display, the screens. So, the screen that they use nowadays, it's basically crystals, and these crystals along with the field, the electric field and the magnetic field, which makes these crystals along the way they are supposed to align. So, we get this screen that we're seeing, the mobile screen. It's no longer the screens that were earlier there. They are all based on crystals now, and the crystals, they move when there is a field applied. So I thought if the crystals can move when there is a field applied, it can be used in this concept also.
Okay. So branch of physics you think is electromagnetic physics. Okay.
Fields.
So the answer is it's quite difficult, very difficult. It's something called statistical physics or statistical mechanics. But I'll give 5 points to particle physics. Like in statistical physics, what you do is you study the behavior of particles, molecules. Like what physics states is atoms or any entity can behave in infinite number of ways. So what is real is a statistical average of a particular system. Okay, so I'll give particle physics very like the proximity to the answer is more, and that is the end of round 3. So every team is neck to neck, just a 5 points difference. Don't worry, this round is a decider because this round is called risky trivia, where it's not just about answering it correct, but also taking calculated risks. Like, there is risk analysis. You have to keep in track of your competitors' points as well. Topic is shown first. You can bid on your points. Suppose if you have 50 points, you can bid up till 50 points, not more than that. If you get it right, takes the point you bid. If you get it wrong, minus half the bid points. That is, if you bid 10 points, if you get it wrong, minus 5. The first topic is journey of a physicist. You will get 20 seconds to decide your bid. Write your bid on the paper, big and bold. Okay, show your paper up. Okay, Team CFL 10 points, 5 points. Team Lourdes 5 points. Team Aloysius 10 points. X's academic journey began with daily arithmetic problems set by his father, fueling his love for mathematics. By 1917, he was lecturing on physics. While teaching postgraduate students Planck's radiation formula, he questioned the way particles were counted and began experimenting with its own theories, which he documented in a report called Planck's Law and Hypothesis of Light Quanta. After his research was rejected by a prominent journal, he sent his quantum formulation to Albert Einstein in 1924. Einstein recognized the significance and applied it to various phenomena. Today, particles confirming his statistics are named after him. His work has led to many breakthroughs, including a particle accelerator and the discovery of God particle. And there has been a collaboration between Einstein and this scientist, which giving rise to new field in physics. Who is this physicist? Your time starts now, 20 seconds. Team CFAL, what is your answer? You can announce it in the mic.
SN Bose.
SN Bose, nice. What made you think SN Bose?
Bosons, the particles.
Particle is named after him. Okay, it's boson. Yeah, makes sense. Nice. Any other clue that led you to think of boson? I mean, SN Bose.
I've heard something about him sending
Bose-Einstein condensate. That is their collaboration.
I've heard about him sending his work to Einstein.
Brilliant. Team Lourdes.
We had the same answer.
Okay, can you confirm it by showing your paper? Nice. Bose. Okay. What's the answer? Neil Bohr.
Yeah, Neil Bohr.
Okay, what made you think it's Neil Bohr?
The picture which you showed.
No, that is not the picture of the question. That was the picture of the topic. Locking your answer, Neil Bohr. And the answer is SN Bose, Satyanath Bose. So Team CFAL, you guys bid 10 points, so you have 55 points. Team Lourdes, you bid 5 points, so you get 5 points, so 60 points. Team Aloysius, you bid 10 points, you lose -5, so 45 points. So the next topic is black hole. You have 20 seconds to decide your bid.
What? If they get it right, about 10 hours, 15 points, we're not coming back. 15. You know, right? Black hole. He doesn't know.
5, 4, 3, 2, 1. Team CFL, 5 points. Okay. Team Lourdes, 10 points. Wow. Taking risk one step at a time. Team Aloysius, 10 points. Okay, nice. X was first proposed in 1974, improving our understanding of black holes. We are talking about a phenomenon suggests that black holes, contrary to classical physics, are not entirely black, but emit a faint glow of particles. X occurs due to quantum effects near the event horizon, where virtual particles pair up constantly and they are created and destroyed. Occasionally, one particle of the pair falls into the black hole, while the other escapes, appearing to have been emitted by the black hole itself. I mean, there has been a contrarian belief that even light can't pass through black hole. Black hole's gravity is such that it even attracts light. This process causes the black hole to lose mass over time, eventually leading to its evaporation. The smaller the black hole, the more intense this radiation becomes. For stellar mass black holes, this effect is negligible. X has profound implication for the fate of information in black holes and the reconciliation of quantum mechanics with the general relativity, making it a cornerstone for modern theoretical physics. What is this phenomenon? Okay, what is this? What is the name of this particle that escaped the black hole known as? You have got 20 seconds. Okay, 5, 4, 3, 2, 1. Okay, Team Lourdes, what's your answer? You can announce it in the mic.
Hawking radiation.
Hawking radiation, so confident, why?
So, it was suggested by Stephen Hawking that black holes, unless they consume other stars, they will eventually lose particles, because at the very surface of the event horizon, particles are being created and destroyed. If black holes, being supermassive and having an extremely strong gravitational field, end up pulling the antiparticle inside, and the particle escapes from the surface.
Are you sure it's antiparticle and particle? Okay, yeah. Nice.
So
I
it
get your
tells
point.
that the empty space is not really empty, and it consists of virtual particles, and those interactions, they are collisions. So in a black hole, the pull is so strong that one of the particles is pulled inside, the other it's out.
Escapes.
So this is
nice. I get your point.
Yeah.
You're saying Hawking radiation.
Yeah, and smaller the particle,
Yes.
more the energy.
Nice, interesting. Team Aloysius.
Hawking radiations.
Okay, Hawking radiation. Any particular points to add which they have missed? Move on to Team CFAL. Hawking radiation. Wow, you guys are brilliant. Okay, let's see. The answer is Hawking radiation. Nice. Everybody gets the points they bid. CFAL, you guys bid 5 points, so you get 60. Team Lourdes, you guys bid very clever, 10 points, so you guys end up at 70. Team Aloysius, you guys bid 10 points, so 55 points. Third topic, scientific controversy that happened last year. Very popular news headline, which then turned out to be false. You have got 10 seconds to decide your risk. Five, four, three, two, one. CFAL 5. Okay. Lourdes 5. Very calculated risk. Okay. Team Aloysius. 10. Nice. I like your spirit. A research paper published in 2023 by a team from South Korea of an institute, Quantum Energy Research Center, claiming that they observed something that sparked one of the most intense scientific controversies of 2023. They came up with a material called LK99, and it was reported to exhibit X at 127 degrees Celsius and atmospheric pressure. The announcement triggered unprecedented global attention, with the original paper garnering millions of views within days. The phenomenon seemed achievable in a modified lead apatite structure with copper and phosphorus, defying conventional theories. However, the claims quickly became controversial when multiple labs worldwide, including those in China, US, and Europe, attempted to reproduce the results. Despite following the published synthesis method, none could replicate the claimed properties what they had claimed. The controversy deepened when experts identified inconsistencies in the original data, particularly in the magnetic susceptibility measurements and X-ray diffraction patterns. By 2023 August, most of the scientific community had concluded that LK99 did not exhibit this phenomenon. What was the controversial claim? Wow, CFL seems confident. Lourdes seems confident. Aloysius looks bit confused. 5, 4, 3, 2, 1. We'll start with the team Aloysius. Announce your answer in the mic.
MRI scan.
MRI scan. So what is the controversial about it?
No idea.
Team CFAL.
Superconductivity.
Superconductivity. What is superconductivity?
Okay, I'm not quite sure what the phenomenon does, but this particular research center claimed that usually it's achieved at extreme conditions, but they could achieve those at the
Normal room temperature and pressure. So superconductivity is no energy is lost during conduction, where electrons move without any friction. So it is observed at very extreme temperature, like absolute zero, that is minus 273 degree Kelvin.
So even our answer is superconductivity.
Superconductivity, yeah. Anything to elaborate?
Otherwise, superconductivity is acquired by liquid nitrogen temperatures, and so. And when this was discovered, it had huge implication. We could create transportation systems which can be easily powered.
Mm-hmm.
Since it's frictionless, there's nothing. We could just turn it off and stop.
And it ended up to be false.
It ended up to be false. Many YouTubers also claim to do this.
Okay. The answer is yes, you guys got it right. Superconductivity at room temperature. So team CFAL, you guys bid 5 points, so 65. Team Lourdes, you guys bid 5 points, so 75. Team Aloysius, you guys bid 10 points, you guys lose -5, so 50 points. Don't lose hope, we still have 3 more questions. The topic is deep space mission. You will have 10 seconds to decide your bid.
We have no answers, right? So let's get this. Next one will be higher price. Last, if we save, right, we'll have at least 50. If we bid 50 and get 50, 100, we'll beat them.
5, 4, 3, 2, 1. Okay, team CFAL 10, 5. Team Aloysius 5. X has been a critical power source for deep space missions since 1960s. Unlike solar panels that become ineffective in the outer solar systems, X can power spacecraft for decades through thermoelectric conversion of its decay heat. NASA has relied on this element's unique properties for missions like Voyager, Cassini, and Mars Curiosity rover. What makes it particularly suitable is its 87.7-year half-life and high power density, producing about 0.54 watts per gram. When used in radioisotope thermoelectric generators, it doesn't require moving parts, providing reliable, long-lasting power. The US suspended its production in 1988 and only recently resumed making in small quantities, leading to careful rationing for space missions. Very expensive element. So what element am I talking about? What is this element? Your time starts now. Okay, we will start from Team Lourdes.
I was thinking about radioactive elements like uranium.
Which one? Uranium. Nice. We'll move on to Team Aloysius.
Antimatter.
Are you sure? Okay, Team
Plutonium.
Plutonium. Okay, what made you think it's plutonium? Why not uranium?
Because that's more abundantly available.
The answer I was looking for is plutonium. So CFL team gets it right. So you guys bid 10 points, right? Nice bid. So you guys end up at 75 points. So Lourdes, you guys bid 5 points, so lose minus 2.5. So you guys end up at 72.5. Aloysius, you guys bid 5 points, so lose minus 2.5, so 47.5. Okay, next topic is laser. You got 20 seconds to decide. This is last but one question, so risk it wisely. Okay, 5, 4, 3, 2, 1. Okay, Team CFL going for 10. Nice. Team Lourdes, 5. Oh. Team Aloysius, 10. Nice. X represents the shortest possible duration for which light can be confined in modern laser pulse. First achieved in the late 1990s, this time scale is so brief that during this interval, light travels only about the width of human hair. This is the shortest possible time we can imagine. At this extreme time scale, traditional electronic measurement become impossible, requiring specialized techniques like autocorrelation. These ultra-short pulses have revealed previously invisible phenomena in chemistry and in biology, allowing scientists to observe chemical bonds forming and breaking in real time. Despite numerous attempts, generating shorter pulses has proven challenging due to fundamental physical limits involving the uncertainty principle. This duration has become a crucial benchmark in ultra-fast science, enabling application in precision manufacturing to medical imaging. So if you go for high surgery using lasers, the lasers are playing with this time scale. So what is this time? Which is the shortest laser pulse duration. Any objection in giving more clues? Oh, all three hands. Nice. Nice. Team CFL, what's your answer? Nano. Okay, 10 to the power minus 9. Okay, 10 to the power minus 9. You think that is the shortest the humanity has achieved? Nice. You mean nanoseconds. Team Aloysius. Ferro. Are you sure with your
10 to the power minus 15.
10 to the power?
Minus 15.
What is that?
Ferrometer.
Attoseconds.
Atto, 10 to the power minus 10. Atto is 10 to the power minus 18. Sorry, yes. Are you sure light can be studied at attoseconds?
There was a Nobel Prize awarded like few years back.
Laser has not gone to attoseconds. Like I told about, it is used in modern eye surgery or laser surgeries. Yes. Yes, 10 to the power? 15 minus 15. Yes, so who gets it right? Okay, Team Aloysius gets it right. Not for the pronunciation, but you said 10 to the power minus 15. Yes. So that's fine. I will give that correction, but no negative for Team Lourdes for coming up with attoseconds. Okay, no negatives. I like the extent and the way you guys have been updated. CFL bid 10 points, so you guys end up at lose -5, so 70 points. Okay, Lourdes, no negative. So you will guys end up at 72, maintaining your winning edge. Nice. Team Aloysius, you bid 10 points, you get 10 points, 57.5. All right, this is the last round. Fluid mechanics. Last round, bid aggressively or very calculated risk. This can decide, make or break. Okay, this can decide your winning position. Since every team is neck to neck, this is highly unpredictable to decide who is the winner. Anybody can be winner, I'm saying. And don't reveal your bid. Keep your bid very secretive. 5, 4, 3, 2, 1. Papers in the air. Okay, team CFAL. 15. Very calculated risk. 15 points. Okay, 50, 5. Oh, Lourdes doesn't want to risk it. Team Aloysius. All in?
57.5.
Whoa! Nice. If they get it right. Okay, let's calculate the predictions. Okay, possibilities, probabilities. Okay, if every team gets it right, CFL would end up at 85. Team Lourdes will end up at 77.5, and Team Aloysius will come out as a winner with 113 points. Oh, tables will turn here. Okay, let's see who will go back home with 1 kg grizzly brownie and the title Mangalore's best physics team. Shall we? Ready?
Yes.
Okay, this is very interesting. A treat for Quizmaster. X are experts at manipulating and directing movement of fluids around them, often with remarkable efficiency. Dr. John Dabbury's research at Caltech found that X create precisely controlled vortex rings during these locomotions by pulsing their body, and that's why they're called the kings of fluid dynamics. These vortex rings, essentially organized swirling patterns of water, generate propulsion forces with remarkable efficiency. This discovery is significant due to its broad applications. The fluid dynamics principles mirrored blood flow patterns in the human heart's left ventricle, leading to innovation in medical diagnostics, where vortex patterns indicate cardiac health. Research shows that X achieve up to 85% propulsion efficiency, inspiring wind turbine designs that mimic their vortex generation, improving energy extraction. Research highlights how nature's fluid dynamics solutions inform renewable energy and cardiac medicine. These are the case studies. So my question is, what is this creature? What is X, who is known as kings of fluid dynamics? Studying this creature's locomotion can inspire next generation wind turbines. You will get 20 seconds. Which creature can you think moves very efficiently in fluid or in the air or anything? Which create vortex, and that gives them propulsion push, which is highly efficient. Let's see who is going back home with 1 kg grizzly brownie and the title Mangalore's best physics team. To be honest, everybody did fantastic. Okay? Everybody did fantastic, neck to neck. I couldn't expect this from a PU level. Okay? As I said, the questions were extremely hard for your level, and you guys did extremely well. And I'm really proud, the smartness, the knowledge you guys are carrying, the younger generation is carrying, is much bigger than the previous generation. So I'm glad at that point. But now let's see who is the winner. Put your paper in the air, everyone. 5, 4, 3, 2, 1. At once. Quickly. Team Aloysius saying? Dolphin. Okay. Team Lourdes saying? No. What is penguin? Penguin, okay. Team Dolphins, okay. What to say? What to say? Let's see the answer. The answer I was looking for, jellyfish. Have you seen jellyfish creating the vortex? So team CFL loses minus 7.5, so 62.5. Team Aloysius bid all in, so minus 27 something. So Team Lourdes bid 5, losing minus 2.5, ending up at 70. So Team Lourdes walks back home with the title Mangalore's best physics team and 1 kg Priestley brownie. Nice, well done everyone. Neck to neck competition. Yes. Yeah, well played everyone. Well played. Neck. That was just close.